Welcome to the deep dive. Ever really thought about the incredible power just rumbling away under us? Today, we're diving deep into volcanoes, trying to figure out why and how these things happen based on some really great source material we've looked at.
Yeah, and we're going to sort of trace that whole journey of magma, where it comes from, deep down, right up to when it bursts out. And we'll connect a few, maybe surprising factors for you too, the hidden mechanics of it all.
Okay, let's kick things off right at the start. Magma formation. Our sources
So,
show it's not just about heat, is it? It starts way down in the mantle, yeah. High temperatures, obviously, but also, this is interesting, less pressure as the rock moves up.
that's it. That's this idea called decompression melting. It's pretty fascinating. Usually, you've got immense pressure keeping rock solid, even when it's incredibly hot. But as that super hot rock rises, the pressure drops off. And it can actually melt, like, without needing more heat. And there's a third thing the sources point out, which is a real game changer: water.
Water? That sounds counterintuitive. How does water get involved in melting rock deep inside the earth? I mean, it's not like there's an ocean down there, right?
Right. Good point. It's not just any water. It's water that gets dragged down, when one tectonic plate slides under another. That process, subduction, this water gets trapped, basically,
Yes.
and it acts like a potent catalyst. It significantly lowers the melting point of the rock it's mixed with, makes magma form much, much easier. And once you have this magma, this molten rock, it's lighter, so it naturally starts moving upwards. It gathers in these big underground pockets, magma chamber.
Right, the magma chambers. And once it's collected there, that's where things really start heating up, metaphorically speaking, because the pressure starts to build relentlessly. The sources describe it almost like a pressure cooker. You've got gases trapped in the magma,
Yeah.
water vapor, CO2.
Exactly. That pressure buildup is the key driver for an eruption. Those trapped gases just want to expand. Eventually, the force inside that chamber just becomes too much for the rock above it. It overcomes the strength of the rock, and bang! The magma bursts through, the trapped gases, the molten rock, everything gets expelled. And that's what we see as, lava flows, ash clouds, all that dramatic stuff.
Okay, so we understand the basic mechanism now. But why are some eruptions these massive catastrophic explosions, while others are more like gentle oozing? Our sources mentioned two distinct styles, didn't they? Driven by the magma itself.
Precisely. You've got explosive eruptions. Think Mount St. Helens, that kind of thing. That happens when the magma is really thick, very viscous, like sticky. It traps gases really effectively, so the pressure builds and builds to an insane degree because the gas can't escape easily. When it finally goes, it's incredibly violent, explosive.
And the other type, the effusive ones, like you see in Hawaii, those amazing lava rivers. What's different there?
Yeah, with those, the magma is much runnier, thinner, more fluid. Because it's less viscous, gases can bubble out much more easily, kind of continuously, so you don't get that extreme pressure buildup. Instead of a huge blast, you get those more, gentle flows of lava. It really just boils down to how sticky the magma is, its viscosity.
It's amazing how it all connects, the magma's properties dictating the eruption style. And speaking of connections, location matters too, right? Most volcanoes are near tectonic plate boundaries, where plates crash together, convergent boundaries. You get magma forming. And where they pull apart, divergent boundaries. Magma wells up.
Exactly. And then you've got the odd ones out, the hot spots. Like Hawaii, they aren't near a boundary at all. These are plumes of superheated rock rising from deep, deep inside the earth, punching right through the middle of a plate. It's this incredible dynamic dance between what's happening way down below and what we see on the surface, constantly reshaping things.
This whole deep dive really underscores what an incredible dynamic process volcanic activity is. From way down deep, starting the melt, all the way to the different kinds of eruptions we see on the surface.
It really is. And what's truly remarkable when you think about it is how these deep earth forces, from something as subtle as water helping melt rock, to just how thick the magma is, how they control such massive and varied events on the surface, makes you wonder, doesn't it? What other hidden processes are constantly shaping our world, just beneath our notice?